So today we're going to be taking a look at some Matrices exam questions. So if you're new around here, be sure to subscribe. I'm going through a lot of A-level further maths revision content. So today let's have a look at some of these questions that we've got. So we start off quite easy. We've just got a matrix here, 2x2 matrix P, where K is just a real constant. Now all these questions are taken from the Core Pure 1 textbook. I think we've got one or two that are from some exam papers. But overall we're using the Core Pure 1 textbook, so be sure to follow along if you want to see the question yourself. So let's get the pen up. So the question's asking us to find the possible values of K if P is a singular matrix. So remember, if a matrix is singular, what that means is that the determinant of the matrix, so in the case of this question that would be the determinant of P, so det P is equal to 0. Okay, so all we've got to do is work out the determinant of this matrix, set it equal to 0, and then just solve. So I've got 3k times minus k, because this is a 2x2 matrix. So all I'll do is I'll do 3k times minus k, so that would be minus 3k squared. I'll do minus, so I'm going to do this bit in a bracket here, just because we've got, obviously I've got 4 minus k and k minus 2, so I'm going to be expanding two brackets as well here. So it's 4 minus k times k minus 2. Okay, and this has to be equal to 0, all of this. So let's just simplify here. So this is minus 3k squared minus, so let's expand these brackets now. So I'm going to get here, I'm going to get 4k, 4 times k, 4k, 4 times minus 2, so that's minus 8, minus k times k, so that's minus k squared, and then finally minus k times minus 2, that'll be plus 2k. And that's all equal to 0. Okay, so now we can simplify this square bracket here. So I've got minus 3k squared minus, well that'll be minus k squared. I've got a 2k and a 4k, so that's 6k. And then we've got minus 8. Okay, this is equal to 0. So now let's just get this in terms of my k's here. So I've got minus 3k squared minus minus k squared, so that means we have to add it, so that would be minus 2k squared. So what we're going to get here, and there's kind of a clue in the question where it says find the possible values of k. What we should get here is a quadratic. So minus 2k squared minus plus 6k, so that's going to be minus 6k, and then minus minus 8, that's plus 8. Now this is equal to 0. And to make life easier here, I'm just going to multiply through by minus 1, so that gives me 2k squared plus 6k minus 8 is equal to 0. And I can actually divide through by 2 as well in the same, in the next line here, so that would be k squared plus 3k minus 4. Still equal to 0. And now this is just a really basic quadratic that you've got to factorise. So for your GCSE maths, nice and easy, that'll give me k plus 4 and k plus 1. So this is still equal to 0. So therefore, we can now just easily work out the values of k. So therefore, k is going to be equal to minus 4 and minus 1. Oh, sorry, that should be a minus 1 there. So k minus 1. I'm going to say something doesn't work out there. So, and k is equal to 1. Okay, so minus that little error there, everything else is perfect. So k is equal to minus 4 and k is equal to 1. So them give you the values to make P a singular matrix. So that's the first question done. So let's clear that and move on to the next one. Now the next one is very similar. So this is exercise 6C, question 13. Same idea again, but this time it's a 3x3 matrix. So for 3x3, we've got to change how we work out the determinant. So to work out the determinant, you need to expand along a single row or a single column. Now, when I first learned this, we were taught just to expand across the top row, and that's kind of always the method I've done. Now, it doesn't matter which one you expand along, it's completely up to you. And as long as you expand everything correctly, you'll still get the same answer. Okay, so if I expand along the top row here now, what I'm going to get is x minus 3, and then we need to work out the individual 2x2 determinant. So if you want to know how to work this out, let me just do it in red, so to make it clear. So imagine, because we're doing it along x minus 3 first, imagine I was to scribble out that column and then that row. What would I get left with? I'd get left with these 4 elements. Okay, so it's going to be x minus 3, and then we need to work out the determinant of x minus 2 minus 1 and x plus 1, like so. And we're just going to keep doing this now along the matrix. So now I go on to the minus 2. So again, I'd be expanding along this row here, and I'm going down this column now this time. So all I'm going to get left with, and remember when we work out the determinant, it goes plus, minus, plus, but because this is a minus, it's going to be a plus again. So it's going to be plus 2, lots of. So I'm going to get 1, minus 2, and then x plus 1. Okay. And then finally, because this is 0 here, doesn't matter what you get actually for the determinant, anything times by 0 is 0. So that will technically cancel, but just so you can see what the method actually is, imagine I was to put this down, it'd be plus 0 lots of, so it'd be that the row there going, and then that column there going. So I'd get left with 1, x, minus 2, and minus 1. Okay, but obviously that will just cancel anyway, so imagine I just scribble that out. So this will be x minus 3 times by, so we do it in the square bracket again, it'll be x times x plus 1 minus 2 times minus 1, which is 2, so it's minus 2 there. Okay, plus 2 lots, so plus 2 lots of 1 times x plus 1, so x plus 1 minus 2 times minus 2, so that's 4, so it's just going to be minus 4 there. And again, what we'd expect here is that if this matrix is singular, the determinant must be equal to 0. Okay, so all this will be equal to 0. Now in this case, what you might notice here is that this time it won't be a quadratic, but within a 3 by 3 matrix, it will be a cubic polynomial. So let's just keep expanding here. So this is going to be x minus 3. So let's put this in brackets now. This is a bit x times x, so x squared plus x, so x squared plus x minus 2. So we'll have to expand that in a second. And I've got plus 2 lots of x plus 1 minus 4. So 1 minus 4 is minus 3. So I've got plus 2x. So 1 minus 4 is minus 3 times that by 2, minus 6. Okay, this is still equal to 0. If I expand this now, x times x squared, that's x cubed, x times x, x squared, x times minus 2, minus 2x. Do the same now with the minus 3, so minus 3 times x squared, I get minus 3x squared, minus 3 times x, minus 3x, and then minus 3 times minus 2 gives me positive 6. We've got a 2x here, we've got a minus 6, and all this is equal to 0. And what you might notice is some things, I'm losing my voice, some things will start cancelling. So that minus 2x will cancel with that positive 2x. We've got a plus 6 here and a minus 6. And I don't think anything else cancels. So what we get left with here now is x cubed. We get a plus, we've got minus 3x squared plus x squared, so that's got to be minus 2x squared. And then finally we've got this minus 3x here at the end. And all this is equal to 0. So now we can just solve this by factorising. So factoring x out, I'm going to get x squared minus 2x minus 3. This is equal to 0. And now I can factorise again here. This is a quadratic polynomial, so we can factorise this hopefully. And what you'll find is it does actually factor for this question. So what I've got now is x times factorising this, so I need something that times is to give me minus 3, but adds to give me minus 2. So that means it's going to be x plus 1 and x minus 3. This is equal to 0. So now we can just simply work out our x values. We've done all the hard work. So therefore, finally, x must be, it'll either be minus 1, it'll either be 0, or it'll either be 3. And there we have it. So that's 4 marks there. That gets you all 4 marks. So let's move on to the next one. So we've got a bit of a shorter one here. We've just got a 2 by 2 matrix A, and we're told I is the 2 by 2 identity matrix. So part A just asks us to prove that A squared is equal to 7A plus 2I. So hopefully the first part's not too tricky. just a little bit of basic matrix multiplication and multiplying by scalars and addition of matrices. So if we do this, I don't have loads of room, so I'll try and do it underneath. So AA. Well, let's do the multiplication first. So a squared, so that's 6 minus 2 minus 4, 1 times x minus 2 minus 4, 1. So if I want the upper left element now of this a squared, I'm going to do this row times this column. So 6 times 6, that would be 36. And then I'd do minus 2 times minus 4, so that gives me 8, so 36 plus 8 there. Okay, so that's my upper left. For my upper right, I'm going to do this row again, times by this column this time now. So that's going to be 6 times minus 2, that's minus 12. And then minus 2 times 1 is minus 2, so we're minus 2. And just a bit of advice for this question. You can actually just do this on your calculator. Okay, so you could just put A in, square that matrix, and then just write the result down. But I'm going to try to do it by hand. Now for this bottom left one, I'm going to do this row times this column. So minus 4 times 6, so that gives me minus 24. 1 times minus 4, minus 4. And then finally for my bottom right element, this row again, times by this column now. So minus 4 times minus 2, that's 8, and then 1 times 1 is just 1. Okay, so if we simplify everything here, 36 plus 8, 44, minus 12 minus 2, minus 14, minus 24 minus 4, minus 28, and then finally 8 plus 1 gives me 9. Okay, but now we need to show that this is equal to 7a plus 2i, right? So we can do this over here. So 7a plus 2i. Remember, I is the identity matrix, so I. So for the 2 by 2 matrix, it's just the leading diagonal of 1. So 1, 1, and everything else is zeros. Okay, so now we need to do 7 times a. So that's 7 lots of 6 minus 2 minus 4, 1, plus 2 lots of 1, 0, 0, 1. Multiply this now, so when you're multiplying by a scalar, just times each individual element by that scalar. So 7 times 6, 42, minus 14, 7 times minus 4, so minus 28, and then finally 7 times 1, 7. Again, just times the ones by 2. So that's nice and easy. So then all we've got to do is add these up. So 42 plus 2, 44, minus 14, can't do anything with that. Minus 28, can't do anything with that. And then 7 plus 2 gives me 9. So are these the same? Of course they are. So therefore, a squared is equal to 7a plus 2i. So we've shown that result. So for 2 marks, that's part A done. Now I'm going to need a bit more room for part B. So if I just clear all this dead quick. Part B is a hence show that. Now you can just work out the inverse of this matrix and then work out half of 8 minus 7i. That is a way you could do it, but seeing as it's a hence that, we'll carry on with that and we'll work through like that. So let's do this. So we know a squared equals to 7a plus 2i. Well, what this is AA is equal to 7a plus 2i, sorry. Well, what we want is at some point to take this in terms of A inverse. So what I'm going to do is I'm going to times both sides by A inverse. So A inverse AA. This is equal now to 7 A inverse A plus 2 A inverse I. Okay. So I'm going to kind of go up here now. I've really not got much room for this. Well, if you've got A inverse and you times it by A, that just gives you the identity, which is just the equivalent of 1, right, in terms of matrices. So this just gives me now A, which is equal to 7 lots of I, because remember A inverse times A, that gives you the identity, so 7I. And then if you've got 2I, like we had here, and you times it by the the inverse, so A inverse here, so we have 2A inverse I. Well, that's just going to give us 2A inverse, right? We can't do anything else with that because the identity is just 1, so it's just 2A inverse. So plus 2A inverse. Well, notice here now we've kind of got the things we need. We've got an A, and we've got an A here. We've got a 7i, like we have in the actual working. But we've got this 2A inverse, so that's kind of problematic. We don't quite want that. So what I'm going to do is I'm going to get this all in terms of A inverse. So rearrange him. 2A inverse is equal to A minus 7i. And notice this is looking even better because that's on the right hand side of what we've got to show. It's A minus 7i times by half. Well, because this is two lots of A inverse, all I've got to do is divide through by 2. So therefore, A inverse is equal to a half times A minus 7i. And there we have it. So that's the final 2 marks. But like I said, for part B, you could have worked out A inverse individually by working 1 out of 1 over the determinant times by when you switch the elements, and then show that's equal to a half of A minus 7i. You could do that method, but I think this method's a bit more elegant and a little bit, you know, seeing as it's hence show that, I think that's a nicer way to do it. So that's that question done. And finally, we've got a question here. So this is from the sample paper 2, from the specimen papers, and it's question 3. So we've got a 3 by 3 matrix, and part A just asks us for which value of A does the matrix M have an inverse. So let's work out the determinant again. So remember, when we're working out the determinant of a 3 by 3, we expand along a single row or a single column. Now, because I'm used to doing across the top row, I'm going to go across the top row every time. So, question 3A. Well, remember, we've got our cofactors as well, and our plus and minus, so it goes plus, minus, plus, minus, plus, minus, so on and so on, right? That would be a 3 by 3 matrix. Now, obviously, for the determinant, we only expand along one row or one column. So, my first one will be positive 2, lots of minus 1, 2, minus 1. Okay, minus a lots of. So imagine you was to cross out the top row and the middle column, you'd get left with 1, minus 1, minus 1, and minus 1. And then finally, the next one will be positive, so it's plus 4 multiplied by the determinant. Again, imagine you get rid of the top row and the third column, the final column, so you get left with 1, minus 1, and 2. So now, we've just got to work out each of these determinants individually. So this is going to be 2 times minus 1 times minus 1, so that's 1, minus 1 times 2, so that's 2. So that adds up to 3, so 2 times 3 here, so that gives me 6. We've got minus a times by 1 times minus 1, so that's minus 1, minus another 1 here, so that's minus 2 there. And then finally we've got plus 4. 1 times 2 is 2, minus a 1, so that comes out as 1. 2 minus 1 is 1. So we just simplify everything here. Minus a times minus 2, plus 2a. And then finally 4 times 1 is plus 4. Okay, simplifying here now. 2a plus 10. Now what we're wanting to show is that the value for which it does have an inverse. So what that's saying is that it can't be equal to 0. But let's just say it's equal to 0 for now and solve it. So that would be 2a is equal to minus 10. Well, therefore a would be equal to minus 5. But that would be if it's singular, right? We don't want it to be singular, so therefore a cannot be minus 5. Okay, so a is not equal to minus 5. Okay, so that's part A, nice easy 2 marks there. Now part B, bit longer, there's quite a lot of work for it, especially for 4 marks. We have to find M inverse in terms of A. So let me just quickly write down the determinant first at the top. So det M, because we will need it, is 2a plus 10. So 2a plus 10. So we'll need that for later in the question. Now, the formula for the inverse of a 3 by 3 matrix is, so in this case it'll be M, so M inverse is 1 over the determinant of m times by the adjoint of m. Okay, so how do we do that? Well, we've already got 1 over the determinant. That would just be 1 over 2a plus 10. But we need to work out the adjoint. So first thing we need to do is work out the minus and cofactors. So how do we do that? Well, let's just quickly write it down. Like we just said before, it starts plus, minus, plus, minus, plus, minus, plus, minus, plus. That's quite tedious. Okay, so them are going to be my signs for this matrix now. And what we do is we look at each individual element and imagine we was to expand there, but we don't multiply by that value. So what I mean by that is if I just quickly change my pen colour, so I change it to red, we'd expand for the very first element, so this plus here, so for this plus here, we'd get rid of that row, that column, and we'd work out that 2 by 2 matrix there. Okay, so what I'm going to do is I'm just going to quickly erase that, and let's work that out so we can see it in practice. So change it to white again. So I'm going to do a very large 3 by 3 matrix just so we can see it. So my first one here is positive, so it's plus my 2 by 2 matrix of minus 1, minus 1, 2, minus 1. Okay, so I got rid of the top row and the first column. We're going to do the same now, but this one's going to be minus. So minus, because remember it goes plus, minus, and so on. So this one's minus, and what's the 2 by 2 corresponding matrix? So it'd be 1, minus 1, minus 1, and minus 1. So I got rid of the top row and the middle column. And again, this one will be plus. So this is all you've got to do now. It's quite tedious and it does take quite a bit of time. You just got to be very careful you don't make a mistake as well. So again, get rid of the top row, last column. So 1, minus 1, minus 1, 2. And you get, with a bit of practice, you can start speeding through these. You get quite used to it. So that'd be A, 4, 2, minus 1. This one's plus. This will be 2, 4, minus 1, and minus 1. Minus again. 2a minus 1 and 2, and then finally we're on to the last row here, so that's going to be a and 4. So I've got rid of the first row, the first column and the, so I got rid of the first row, the first column and the last row here, so we'll just make sure I got that the right way around. So a4 minus 1 and minus 1, so that was a plus, this one's a minus. So that's going to be 2, 4, 1 and minus 1. And then finally it's going to be plus 2a 1 and minus 1. Okay. So that's my large matrix here with my minus and cofactors. Now this matrix is usually just called C. So if I call this C now, okay, well, what we're going to have to do now is work out each of these individual 9 determinants. So, do it over here. C will be equal to, so hopefully this is nice and easy because it is just 2 by 2 matrices. It's only the maximum number it goes up to is 4, so it's not too tricky. So for example, minus 1 times minus 1 is 1, minus another minus 2 here, so that adds it on. So that element there would be 1 plus 2, giving you 3. Okay, and make sure you match it with the corresponding sign. So for example, this one here now, it's 1 times minus 1, so that's minus 1, minus another 1 here, so that's minus 2, but because I've got a minus here, it's minus minus 2, so that middle element becomes 2, for example. Okay, now I've already worked these out, so make sure you do these yourself individually, so pause it now, make sure you can work these out individually, but I'm just going to write the answers down for them all. So your next one will be 1, this one will be a plus a, 2, minus 4 minus a, 4 minus 8, 6, and then finally minus 2 minus a. Okay, so then are my 9 individual results for the determinants. The next step is we need to write down the transpose of this, so we do C transpose, and then what that gives me is the adjoint. So therefore, what we can say here is C transpose is the adjoint of M. So all I've got to do is transpose this matrix. So if you're unsure how to transpose a matrix, I'm going to do it up here because I've literally run out of room. So CT, well, how do I do that? Well, that'll just be, so you take this first row here, so the first row becomes the first column. So all I do is literally switch it. So my first row was 3, 2, 1. My first column now is 3, 2, 1. Okay, look at your second row. That becomes your second column. So A plus 8, 2, and minus 4, minus A. And what you will notice when you do this is the diagonals clearly stay the same, right? So I should get 3, 2. That'll be minus 2, minus A. And what you'll get here is that that's the final row. So your top one is minus 4, minus A. Or was that 4? That's 4, sorry. So that's a positive 4. That little sign there threw me off. So that's not a minus. So 4 minus A, and then this one here will be 6. Okay, and then close the matrix, which I've run out of room to do. So that's C transpose. So all I've literally got to do now is do 1 over the determinant times this matrix, and that's M inverse. So to do that, I'm just going to rub this out. I'm going to try and rub all this out here, just so we've got enough room to finally give the last answer. So we quickly rub all this out. So finally, let's just write down the final answer. So M inverse, therefore, it's 1 over the determinant, so 1 over, like we had at the top, 2A plus 10, times by C transpose here, which is my adjoint. So I'm going to times this by 3, 2, 1, A plus 8, 2, minus 4 minus A, and finally 4 minus A, 6, minus 2, minus A. And there we have it. So that is M inverse there. Okay, and that will work every time. And for a lot of these questions, you need to be confident on how to work out the inverse. You can do it on your calculator, but obviously with these questions, they'll always put a variable in usually, which means you can't do it on your calculator. You need to know how to do it by hand. But there we have it. So that is all 4 marks for that one. So I hope this video has been helpful. That's the final question for this video. Be sure to subscribe and take care, guys.